Parameter and statistic. Now, when to use the word parameter and when to use the word statistics. See, parameter is to be used when data are collected from the whole population. Okay, when you are collecting the data from the whole population and whatever you compute, that will be called a parameter. When from the whole population data, if you are computing mean, then this mean will be represented by mu. Okay, but if you collect the data, statistics is to be used when data are collected from the sample. So when you take a sample and when you collect the data from the sample, then whatever you calculate, if you are calculating mean, then that mean will be represented by either small m or it may be represented by capital M. And in research, we always collect data from the members of the sample, not from the entire population, because it is not possible to collect the data from all members of the population. So whatever I will now use will be the statistics. Okay, this is one important thing which I thought I should tell you. Another important thing, whenever you have the quantitative data, when you have the quantitative data, we only can do two things. Number one, we can compare, or number two, we can study the relationship. Either you can compare or you can study the relationship. There cannot be the third thing which you can do. Now, whenever you want to compare, so you have the central tendency. And these central tendency, you know, are mean, median, and mode. I'm sure you know when to use the word mean and when to compute mean and when to compute median and when to compute mode. Now, when you want to compare, then will you compare on the basis of mean or median or mode? Just think about it. And if you say that you will compare on the basis of mean, then the question is, why not on the basis of median, or why not on the basis of mode? Think about it. Within a second, I will give you the answer. See, when you compare mean, when you compute mean, then the entire collected data are used. But when you compute median or mode, you are not using the entire collected data. Let us take the case of, suppose I have these values, now if I have these values and 2, 6, 8, 10, and 6, then the question arises, what is the mode? Mode means the maximum occurrence, the value which occurs maximum time is called the mode. Mode refers to maximum occurrence, refers to the maximum occurrence of the event. Now, you know here in this particular case, what occurs maximum number of times? 6 is occurring twice. So 6 is the mode. I repeat, 6 is the mode because 6 occurs 2 times. 2 is occurring once, 8 occurs once, 10 occurs once. So in this particular case, the mode is equal to 2. Now, when I computed mode is equal to 6, so in this case, the mode is equal to 6. Then you know, in the computation of mode, I did not use 2. I did not use 8, and I did not use 10. So that means when you compute the mode, you are not using the entire collected data. You see, if you want to open a shop where you want to sell the tea leaves, which tea leaves will you keep more? You will agree with me that you keep that tea leaves more in quantity, which is more in demand during that particular period. So therefore, you are using mode in your daily life. Now, what will be the median in this particular case? To compute median, I will arrange the given numbers either in the ascending order or in the descending order. Let me arrange them in the ascending order. I have 2, then I have 6, then I have 6, then I have 8, and then I have 10. Now here, which is the middle one? This 6 is the middle one. Okay, and therefore in this case median is 6. Median means the middle one, the point above which 50% of the cases lie and below which 50% of cases lie. So this is the middle one. See, when you have seen the seesaw, in the seesaw, that one rod is in between. Okay, when you have the balance, not a spring balance, but your other balance you have in middle. Your cycle pedal is in the middle. So there are many examples where you use median. Now, while computing median, you are not using the complete collected data. But if you calculate mean, then you are using the collected data, 2 plus 6 plus 8 plus 10 plus 6. And this has to be divided by 5. So when you compute mean, the entire collected data will be used. And that is why whenever we compare, we always compare on the basis of the mean. Because when you compute mean, you are not using some part of the collected data, but you are using the entire data, whatever you have collected. So there are different statistical techniques have been developed by the statisticians for comparing the means. Okay, so whenever we have to compare the means, so that means there must be at least two observations. If you have only one, you can't compare. So there should be two sets of the data. If you do not have that, then you cannot compare. So we always compare on the basis of mean. I hope this point is clear. We do not compare on the basis of median and on the basis of mode. So you do not have statistical techniques which can be used for comparing the modes and the median. Okay, now we proceed further. So now we have the statistical techniques. And for each statistical techniques, there are assumptions. If your data do not fulfill the assumptions underlying that statistical technique, then you cannot use that statistical technique for analyzing the data. I repeat, for each statistical technique, there are assumptions. And if the data do not fulfill all the assumptions for that particular statistical technique, then you cannot use it for analyzing the data. This is very, very, very simple, and it is now not difficult to understand. So each statistical technique will have assumptions. Okay, and your data must fulfill those assumptions. So when I take a statistical technique, I will tell you the assumptions. Number one. Number two, I will also tell you what should be the wording of the objectives. So I should tell you the assumptions. Then I will tell you what all statistical technique, what after assumptions, I will also tell you how to write the objective, the wording of the objective. If you want to analyze the data with the help of one statistical technique, then what should the wording of the objective? And dear friends, I will tell you, majority of the researchers, they have the wording of their objectives, which is technically incorrect. I will tell you that when I'm writing the objectives. Then I will also tell you the wording of hypothesis. How exactly the hypothesis has to be worded. I do not know to what extent you people understand the hypothesis. You know, there are types of hypothesis and there are forms of hypothesis. And majority of the researchers are very, very confused between the types of hypothesis and forms of hypothesis. So with respect to the hypothesis, I will tell you these two things, that there are three types of hypothesis. I will not tell you more. One is called research hypothesis. Another is called statistical hypothesis. And the third one is called operational hypothesis. Now, as a researcher, you should know these three. Now, it is your choice whether you want to formulate the hypothesis, the research hypothesis, or statistical hypothesis, or operational hypothesis. It is your choice. There is no need of asking anyone. If you want to formulate research hypothesis, you can formulate. If you want to formulate statistical hypothesis, you can formulate. But if you want to decide about the forms of hypothesis, and the forms of hypothesis are two. One is called null form, and another is called directional or alternative. Now, when you say null form, then you must know when to formulate hypothesis in the null form. To decide the form, there are bases. And these bases you must have studied. I'm not going to tell you. Okay? When should you formulate hypothesis in the directional form? Again, there are bases. It is not your sweet will that whenever you want to formulate hypothesis in the null form, you formulate in the null form, and whenever you want to formulate in the directional, you formulate in the direction. No, it is not the sweet will of the researcher. For deciding the forms, there are bases. One of the bases is called review of related literature, not review of literature, review of related literature, and another is called theory. Okay, so therefore, the hypothesis we normally formulate in the null form. Why? Because we do not have strong evidences and strong base to give a direction. To give direction, you have to have very strong base. You know, many a times the Supreme Court leaves some of the people because they do not have very strong evidence to support that these people were involved in that particular crime. So if you do not have strong support, then direction cannot be given. It has to be the null form. So whenever I formulate hypothesis, I will formulate it in the null form. Okay, all right. So let us say, so I'm now taking a statistical technique, and then I will start writing, telling you the assumptions, and then I will tell you the objectives. Okay, I'm telling that first I take, let us say, I'm taking t-test. T-test, another name for this is independent samples t-test. Please understand, it is not sample. It is not independent t-test. No, it is independent samples t-test. So it is important for each one of you to know the correct name of the statistical technique. Another thing you should know, it is a small t. It is not capital T. Please understand. These T's are not capital. So you cannot write capital T. If you write capital T, then it means you are not using the correct symbol for the t-test. So it is important for you. There is another name, and the third name is students t-test, because this was developed by the students, so it is also called students t-test. Now, the assumptions. The assumptions are like this. One of the assumption is that whatever the variable that you have, yesterday I told you the types of variable, and I said there is a continuous variable and there is a discrete variable or discontinuous variable. Then I did tell you in experimental study, you can use the word independent variable and dependent variable. Intervening variable has to be in experimental study as well as in survey researches. So intervening variable will, but in survey research, you cannot use the word independent variable and dependent variable. So whatever is the variable that you are having, it must have normal distribution. And when I say normal distribution, it is normal distribution of the variable which is continuous variable. Because the continuous variable will only have a distribution, not discontinuous variable. So it must be normally distributed. The another assumption is homogeneity of variance. So what is the meaning of homogeneity of variance? Homogeneity of variance means whatever are the differences in one group, the same magnitude differences exist in another group. And this you can denote it by the small s, and it has to have a square. So small s square, okay, and here you have S1, then you have the square, then you have equal to, then you have S2 square. I'm just changing and by doing this, because there are two groups. So S1 square is equal to the S2 square. That is the meaning of homogeneity of variance. And this is a small s. So you can make it a small s, no problem at all. Or if you use sigma, you can use sigma. Normally, sigma is to be used when you are taking the data from all members of the population, because that represents the population. And s, small s, represent the standard deviation of the sample. Okay, now another say assumption said your data must be either on the interval scale or on the ratio scale. Data must be either on interval scale or ratio scale. And the fourth is there should be no outliers. Outliers means there should not be extreme scores, neither on the higher side and not on the lower side. By chance, if there are some extreme scores, then while analyzing the data, you should take them out from your data. And when you take them out, then your sample size reduces. It does not make a difference. That's perfectly correct. Let it reduce. But then you know that assumptions must be fulfilled. These are assumptions, and assumptions cannot be tested. They have to be satisfied by the data. So that is why some of the people, they use assumptions and hypothesis interchangeably, which is technically incorrect. Because hypothesis can be tested, but your assumptions cannot be tested. They have to be fulfilled. So these are the assumptions. So your data must fulfill these assumptions. And if fulfilled, then fine. You can definitely analyze your data with the help of a t-test. Now let us see, how do we write objective? How do we write objective if you have to analyze the data with the help of independent samples t-test? Okay, so I'm writing objective. Now I'm taking one objective, and let us see, I'm taking very simple, a variable which is very, very common and everybody will understand. Because all of you were the student at one point of time, and you must have appeared in different examinations. There are marks, and you can always take the average of all the marks. So if suppose I have a situation, please see, it is independent samples. If it is independent samples, then it is important that I must have the two groups. And if I take a situation like this, suppose I take one variable as gender, and if I take gender as a variable, then there are two levels. One is called male and another is called female. So male and female are the two levels of gender. Okay. If I take, let us say, residential background. So residential background, I can take urban, I can take semi-urban, I may take rural. Or if you like, I may take just two, urban and rural. If I'm taking two, then I can take two. If I want to three, I can take three. Absolutely no problem. Like this, you can have a variable which will be discontinuous variable or which will be discrete variable. So you should have one variable having two levels. This is the one condition, and another condition is you should have another variable which is criterion variable if you are doing a survey research. But if you are doing an experimental research, then it has to be dependent variable. And you know, dependent variable or the criterion variable will be continuous variable. It cannot be discrete variable. So if I take one criterion variable, like I'm taking one criterion variable, say achievement in English. You know how to collect the data related to the achievement in English. So you can do it very well, no problem at all. Okay. And if suppose I'm taking the sample, say class, say 10th students of government higher secondary schools of, say, Delhi. This is my sample I want to take. Okay. And if I want that, then of course, the sample will not be the part of the objective, that will be the part of the title. So I'm not telling you how to write title. I'm just telling you now how to write objective. Now I have to write to compare achievement in English of male and female students. Just read and think about it. Is it all right? Or should it be like this? To compare mean scores of achievement in English. Please just read both these and tell me which one do you think is the appropriate wording of the objective. Anyone like to tell me the appropriate wording of the objective, whether it is objective 1 or objective 2? You can unmute yourself and you can tell me the answer if you have. Okay. Now you know the first objective is not all right, because you cannot compare the achievement in English of one male with one female, the one male with one female. No, it is not possible. So therefore, the correct wording of the objective is the number 2. So number 1 is not the correct wording of the objective. So if you have to write objective whose data you can analyze with the help of a t-test, so this is the correct wording of the objective that you should use. And if this is the correct wording of the objective, then let us say, how do I write my hypothesis? Now the hypothesis for this will be, now when you are writing the hypothesis, you have to write the hypothesis in the present tense. You cannot write hypothesis in the future tense. Why? Because there are bases, and keeping those bases in the mind, you are formulating the hypothesis. So it has to be written in the present tense. So the hypothesis will be, there is no significant. I told you that we use the word no because we are formulating null form. So because the hypothesis is formulated in the null form, so we are using the word no. And I have to use the word significant. Is important because in some books it is written that the significant word they have not used when they were formulating the hypothesis. But in the same book, at some other place, I found that when they wrote a hypothesis, they did write the word significant. Dear friend, it is very, very, very important to use the word significant. Okay? And I know you know the meaning of significant. So there is no significant difference in mean scores of, I can copy and paste, of achievement in English of male and female students. If this is my objective and this is my hypothesis, then how will I now analyze my data? So let me go back to my SPSS, and in SPSS, I will enter the data. You know, there are two variables related to which you need data. Number one is achievement in English, and another is your gender. You should know whether this student, class 10th student, is a male student or class 10th student is a female student. It's a very important thing. So therefore, let us go back to my SPSS, and therefore I'm going to the SPSS. Are you able to see this particular screen? Hello? Hello?
Hello.
Are you able to
जी सर. जी सर.
दिख रही है?
हाँ सर, दिख रहा था अभी.
Okay, all right, thank you very much.
अभी नहीं दिख रहा.
अभी नहीं दिख, मैं अभी की तो बात कर रहा हूँ.
अभी नहीं दिख रहा है सर.
All right, okay, don't worry about it. Let me share my screen. I am sharing. Okay, all right. अब दिख रहा है क्या?
हाँ सर.
SPSS की स्क्रीन है. प्रमोद,
We are looking your screen.
are you able to see
The
that?
screen is
Yes sir.
visible,
Yes sir.
All right, okay, all right. So this is the SPSS screen. Yesterday I told you that we first of all go to the variable view, and in this variable view, we are already in the variable view. According to our objective, there are two variables. One variable is gender and another variable is achievement in English. So it is my choice whether I should enter the data of gender first or achievement in English first. It does not make a difference. The sequence may be anything. If I say gender, then I write gender, and I know gender is discontinuous. So I know there are two levels. So I under level, I put 2. Then I go to values. And here, if you click, you get a value labels. Now here I'm saying 1. And if I say 1 means males and 2 indicates females. Now so this is how I have defined. I need not to bother about the measure. Don't bother about it. It does not make a difference. Another is achievement dot in dot English. And achievement in English is a continuous variable. So there is no need of writing any levels. Okay. So once you have written, then let us enter the data. This is the sheet where the name of the variables, they appear. Yesterday I told you this is the first person, and you know what is the gender. Gender is female, and female means 2. And what is the score of this person? Say out of 50, suppose it is 29. Then you go to the next person. Who is the next person? Is a male. And then find out what is the score. Is say 24. So this is how you can go. First person, you can enter both, or you can enter the gender information of all people, and then you can enter their achievement in English. The choice is yours. It does not make a difference. So let me just enter the data first of gender. So I'm entering the gender data. This is how you can enter, but please, whatever you get from the field, you should enter that. At present, I do not have the data from the field. I am just giving you the data. But do not cook the data. Please, this is dishonesty. And in research, we should not have dishonesty. It is an ethical issue. I need not to tell about all these things. You are intelligent and you know more than what I know. Now, I start entering the information of each person related to achievement in English. So I may start again from the beginning, or I may start from the last and go to the up. The choice is yours. I may start from the bottom and I can enter the data, and then I go to the. This is how I'm just entering the data. So if you have your SPSS with you, so you can also keep on doing the way I am doing, so that you can understand it. So I have entered the data. Now I should go to analyze. And because according to the objective, I have to compare means. So I go to the compare means. But one thing I tell you, before you start analyzing the data, you must make ensure that you have entered the correct data. So whatever the data has been entered of the gender as well as achievement in English, you should compare with your original sheet. And if there are some corrections to be made, either in the entering of the gender information or the achievement in English, you should correct it. Because if you will not correct, then this lacuna will remain in the data and it will definitely affect your result. So it's important that whatever information you enter, it must be as per your data which you have collected. Now I am comparing the means, and you know, they compare the means में independent samples t-test. Please, two things you should note. If you see on the left hand side of independent, there is a small t. On the left hand side of the independent, there is a small t. But when it is independent samples t-test, this is capital T. This is technically incorrect. Actually, in the earlier versions of the SPSS, this was not small t, it was capital T. And this mistake was pointed out, and the people, those who developed SPSS, they have changed here, but they did not change here. Therefore, it is important for you not to directly copy the output and paste it. If you copy the output of the SPSS and paste it, there will be a lot of problems. So see what we have to do. So therefore, now I have to analyze the data with the help of independent samples t-test. So I click here. The moment I click, I get this one, and here on the left hand side, right hand side dialog box where my cursor is, there is nothing is written. But here there is a heading like test variable or variables. What is the meaning of the test variable? Means that variable whose mean you want to compute and you want to compare. So you want to compute the mean of achievement in English. So this must be shifted on this side. Then next is a grouping variable. Grouping variable means this is discontinuous variable, and your gender is a discontinuous variable. So you select gender and you can shift it to the grouping variable. As soon as you shift here, there are two question marks in the bracket. Okay, and now you click define groups. Now you have defined your groups as 1 and as 2. 1 means male, 2 means female. So 1 represents the data of the male and the 2 represents the data of the females. So now I can continue. And as soon as I continue, see now this is active. Earlier it was not active. Let us see the options. In the option, your confidence interval is 95%, you are confident that this result will come. And if you are 95% confident, that means the error is 5%. the error is, that means 5% you are not confident that this result will come. Why? Because it may be due to some error. So when you have the 95% confident or 99% confident, but if you have to talk in terms of the level of significance, it is 0.05 or 0.01. In social sciences, the maximum allowed error is 5% and minimum is 1%. But in pure sciences, they do not have error 1%. They have less than 1%. Sometimes they have 0.1% error. And their level of significance 0.0001. Then it is 0.1% error. So this is how it goes. So it is 95%. If you want to change to 99, you can change. But by default, it will be 95 because maximum allowed error is 5%. Okay, so we go ahead. We need not to do anything. Now, this is the output. This is the output of your result. Now understand here two things. Very, very clearly you should understand two things. Number one is, here it is a group statistics. So what they have is the males. How many? 20. How many females? 21 females. What is the mean score of achievement in English of male? It is 27.47. Let me write. So it is for male is 27.478. So because it is 0.478, so I can make it 0.8 because the rule of approximation. And in case of your females, you have 21 females and the mean is 31.619. So I'll say 62. So it is 31.619. So I say 31.62. And my standard deviation of male is 5.375. So therefore I'll say 5.37, because if it is more than 0.5, then you can increase by 1. For the female, it is 3.866. So 3.87. Now, after this, it is the standard error of the mean. Now, either you can use standard deviation or you can use standard error. Because standard error, all of you know, is calculated from the standard deviation. I repeat, the standard error is calculated from the standard deviation. And you know the formula of calculating standard error. So it is standard deviation divided by under root of n or n minus 1, depending upon sample size, it is large or small. So from this particular table, the group statistics, I need the information about n, I need information about mean, and I need information either standard deviation or standard error. Only one. You need not to write both. Now then, it is independent samples test. And see, this is capital T test, which is wrong. It has to be small, but don't worry about it. Now, proceed further. Here you see that there are two important things. One is equal variance is assumed and equal variance is not assumed. I told you when I was telling you the assumptions which must be satisfied by the data. Okay. And now in this case, in order to study whether you have a homogeneity of variance or not. Now this is a test which is Levin's test for equality of variances. So it is Levin's test for equality of variances. Now here, this is the F value they have calculated. And this F value is 5.785. And in this one, the error is only 2%. So that means this particular value is significant. This F value is significant. And if this F value is significant, why significant? Because the maximum allowed error is 5%, but in this case, it is only 2%. So it is 0.021. If you multiply it by 100, you will get 2.1%. So your error is 2.1%. It is less than 5%. So that means this value is significant. Now, what is the meaning? The meaning is whatever are the differences within the achievement in English score of the male and the difference within the achievement in English score of the female, these differences are not same. They are different. That means the equal variances assumed condition is not satisfied. I repeat. So equal variances assumed condition is not satisfied because this F value is significant. So that means the equal variance is not assumed. This condition is satisfied. So we should take this value of the T, the lower value of the T, and the value of the T is 2.952. And when it is 2.952, your degree of freedom, just see, it is 39.901. It is in fraction. So the important is, can the degree of freedom conceptually be in fraction or mathematically be in fraction? So dear friends, because whatever you have studied, some of you might have studied that the degree of freedom mathematically can be in fraction. I repeat, the degree of freedom can be in fraction mathematically, but conceptually it is not in fraction. Conceptually, it will always be in the whole number. This is important for you. So in this particular case, the data which I have taken, in fact, I should not take this value of the T, that is 2.908. This value I should not take. I should take the value of 2.952. And this value is significant at 0.005. So you can say this is significant at 0.01. Because in social sciences, the maximum, okay, the error you are allowed is 5% and minimum is 1%. So your level of significance either can be 0.05 or 0.01. So therefore, this value is significant. And when I am using this particular value, which is a lower one, then I should use this degree of freedom, which is 39.901. I should not use 42 as a degree of freedom. And level of significance is 0.01. Now, you see, whether you see equal variance is assumed or equal variance is not assumed, in both the cases, the t-value is significant. And it is significant at 0.01 level as well as 0.01 level when equal variance is assumed. And when equal variance is not assumed, then also it is significant at 0.01 level. So your result will remain the same. There is no difference in the result. But sometimes your equal variance is not assumed, t-value may be significant, but equal variances assumed t-value may not be significant. This is possible. I repeat that if your Levin's test for equality of variances is significant, then it is possible that your equal variances assumed t-value may not be significant, but equal variances not assumed t-value may be significant. And this is important, and I will give you the reference also. You can write down the reference. The title of the book is Business Statistics. I repeat, Business Statistics. And the author is Ken Black, K-E-N, Ken, B-L-A-C-K, Black. Okay. Now, so therefore, from this particular one, I will take the t-value and I will take this bottom t-value. Now here you see the t-value they are showing as negative. It is negative because in the formula which they have used in their program, it is 27.47 minus 31.61. Because minus value is higher, so that is why it is higher. I will analyze it again. Now I say here, instead of 1, I write 2 first and 1 second. Now just see, now this t-value is positive. You see this equal variance is not assumed, value is minus 2.952. But in this case, it is 2.952. It is positive because t refers to the difference. And difference is always a scalar quantity. It is not a vector quantity. Those people who belong to science, they know there are 2 types of quantities. One is a scalar quantity, other is a vector quantity. The scalar quantity will always give you the magnitude, and the vector quantity will give you the magnitude as well as the direction. So in this case, although in the output it is minus is written, but you should use it as plus. Okay, all right. So therefore, let me write down the t-value is 2.952 and my degree of freedom is 39.90. So let us see how do I now use this output to test my hypothesis and to interpret it. So then I go to my, again, the same sheet. Pramoji, are you able to see this, my Word file? Hello?
Yes, sir.
No, sir.
We are
Yes,
able
sir,
to
we can see it.
see. We are looking.
ये ऑब्जेक्टिव और हाइपोथेसिस दिख रहे हैं क्या?
No, sir.
बड़ा को
वही तो मैं पूछ
हाइपोथेसिस नहीं दिख रही है.
हैं? तो वही तो मैं पूछ रहा हूँ ना, और क्या पूछ रहा हूँ मैं? ओके, तो लेट मी.
Only T test table.
नहीं, मैं आ रहा हूँ, कोई बात नहीं. आप दिख रही है?
Now it is visible, sir.
Yes.
Now it is visible.
All right. So therefore, I have analyzed the data according to my objective. It was the T test. I have analyzed it. Now I'll tell you how the hypothesis has to be tested and how the interpretation has to be done. Hypothesis testing is a part and parcel of the interpretation. So here, from the objective, I must write a caption heading, and the caption heading will be in capital. It is gender-wise comparison of mean scores of achievement in English of students. Now you can see this is my objective, and from objective I have taken the information to write this particular caption heading. And this caption heading should not be from one end to the another end. You should break it so that you are able to differentiate it from your sentence. So this is the heading. And now I start writing. I'll say the first objective was, it has to be written in the past tense because you have collected the data, you have analyzed the data, and now you are writing. So it has to be in the past tense. So to compare, the first objective was, so let me copy the objective. The first objective was to compare mean scores of achievement in English of male and female students. The data were analyzed with the help of, if you want, you can write t-test, or if you want, you can write independent samples t-test. The choice is yours. With the help of t-test, and the results are given in table 1. Results are given in table 1. So now let me make a table. So here I'm going to insert the table. So you can see when I insert the table. So I go to the table and I am inserting it. So this is insert. I want auto fix. So I say auto fix. All right, fine. Now here, this will be your table 1. I will say what is the type heading I will write. Now, here your variable is gender. Then you are writing the mean. Then you are giving standard deviation. Then you are giving n. And then you are giving t value. Okay. So your gender is, say, male. Okay. And your another is, let me take it on the next page. So one is male and another is, say, female. And your mean achievement in English score of male is 27.48, of female is 31.62. Your standard deviation in case of male is 5.37, in case of female is 3.87, and your males are 23 and your females are 21, and your t value is 2.95. Now this t value is significant. So there are two ways of writing is, it is significant at 0.01 level. So I can put double star here, and below I can write double star and I say significant at 0.01 level. This is the one way. If you do not want to put a star, then you cannot write like this. Then you add one more column here. And then here you write remark. And it is significant at 0.01 level, then I say P. P means probability is less than 0.01. Now the moment I write 0.01, this has become capital. Now P should always be small. You have to be very, very careful in writing the symbols. T is a small, not capital. P is small, not capital. Okay. So P is small, it represents the probability. So that means the error is less than 1%. And now here I have to write this table heading. I will write gender wise. What are the information I'm giving? Gender wise mean, SD, N, and T. And T value of what? Of achievement in English of students. So this should be the caption heading, and it is very clear that whatever information you have entered in the table, from that you can take out this. Now let me start interpreting and testing the hypothesis. Both will be done together. So I'll say from table 1. From table 1, it can be seen that the t value is 2.95. Please see, many students, they write that the calculated t value. Please should not use the word calculated, because you are referring to the table, and whatever information you are giving in the table, this information is only after your calculation. So all these are the calculated values. You should not write that. You should not use the word calculated. If you want to improve the quality of your interpretation, you should be careful in using the words. So from table 1, it can be seen that the t value is, it is not values. T is only 1. Here I have written values, gender wise mean value, standard deviation value, n value and t value. So this values is for all these statistics, mean, standard deviation, n and t. So here it is all right, but here it is t value because there is one value, is this, which is significant at 0.01 level with df equals. Now here you have to write the df. And now df, as I told you, you have to write depending upon whether homogeneity of variance condition is satisfied. If you are taking that t value, then you should write the degree of freedom which is written there. Otherwise, here it was 39.90. And when you are writing this, you can write the reference also black. You can give the reference of this particular book, black, 2004 it is. And when you are not writing it in the fraction, then you need not to give the reference. I repeat, when you are mentioning the degree of freedom in the fraction, it is better to give the reference because many of the people in the field do not know that degree of freedom conceptually cannot be in fraction, but mathematically it can be in fraction. Because most of the people, they use the book written by Garrett. Garrett does not talk about these type of things. So the books do not give you the complete information. Some books give some information, some books give some information. So it is important for you as a learner, you should read books written by different authors belonging to different subjects. Because research methodology is being taught in all the subjects. So that's what you should try to understand. Okay, so this I have written. Now it indicates that the mean scores of achievement in English, mean scores of achievement in English of male and female students differ significantly. Female students differ significantly. And when it differs significantly, then what will happen to the null form of the hypothesis? Then you say, thus, the null hypothesis that there is no significant difference in mean scores of achievement in English of male and female students is rejected. The moment you write the word is rejected or is not rejected, the meaning is that you have tested the hypothesis. So testing of the hypothesis is the part and parcel of your interpretation. Okay, so this is important. Now you can see I have written 3 sentences and all 3 sentences are interrelated. So of these 3 sentences, not a one single sentence is redundant. All are important and they are linked with each other. Now I proceed further. Further, the mean score of achievement in English of female students is 31.62, which is significantly higher than those of male students whose mean score of achievement in English is 27.48. This sentence is important because it will give that whose achievement in English is higher. So it's clear. So therefore you can say it may. You are writing may because it is only one research you have conducted. So you cannot be very, very sure. So it may therefore be said that female students were found to have significantly better were found to have significantly better achievement in English as compared to male students. Now, if you copy this sentence, it becomes your finding. So if you are moving systematically, then writing finding is not at all very difficult. It is very easy. So this is how you should analyze your data and you should interpret like this. Now let me take another objective and then I want to take another hypothesis and then I want to use another statistical technique. Now, the statistical technique which I will use is called, it is like this. Say, I will take the, okay, let us say I will take one group of people, doesn't matter. Suppose you are taking their weight. And this I call it a pre-weight. You have taken the pre-weight of the people. These are the weights you have written. Okay, I can take it on this side, no problem at all. Okay, so these are the pre-weight you have written. and then you have given them some exercise, and after the exercise you are again taking their weight, post weight. And suppose their post weight are something like this. Now, then I can compare, I can compute the mean here. If this mean is M1, and I can compute the mean there, and this is my M2 mean. Now, you have the mean of the pre-weight and you have the mean of the post-weight. Now you want to compare them. For comparison, now you do not have two independent groups. You have only one group. And when you have only one group, so this is my weight and this is my weight. This is Pramod Kumar's weight. This is Pramod Kumar's weight. This is Ram Kumar weight. This is Ram Kumar weight. So my weight before the exercise and my weight after the exercise. So there is a correlation between my weight and my weight. So there will be correlation between pre-weight of the people and the post-weight of the people. So they are correlated. So therefore, in this particular case, if you have to analyze the data, then the data which you analyze and that statistical technique which you use, the statistical technique is called correlated t-test, or you can say paired samples t-test. I become my own pair, you become your own pair, the other person becomes his own pair. So see, here I cannot use independent samples t-test. This is very important. So if this is the case, then how do I write my objective? My objective will be to compare mean scores of weight of subjects before and after the exercise. To compare mean scores of weight of subjects before and after the exercise. If this is my objective, then what is my hypothesis? Then my hypothesis is there is no significant difference in, I just copy from here to here and I paste it, and therefore that becomes my hypothesis. There is no significant difference in mean scores of weight of subjects before and after the exercises. If this is so, then how do I enter my data into the SPSS and which statistics I use to analyze the data and how exactly the interpretation has to be done. So let me go back to my, are you able to see it?
Yes, sir. The Word file is visible.
Not Word file, SPSS file, is
No,
it
sir. No, that is not visible.
at present, is it visible
No, sir.
right now?
Yes.
Is it visible?
Yes, sir. It is visible.
Okay. Now see, from my objective, it is clear. I must have weight before the exercise and weight after the exercise. So I go to my variable view and here I am saying pre-weight. It is a continuous variable. Then I have post-weight.
Sir, sorry to interrupt. It's not visible to some of the candidates, sir.
I can't do anything. If it is visible to you, it should be visible to others also. Are you able to see it or not? Are you able to see or not?
No, sir. Now it is not visible. Earlier it was visible.
All right. All right. Okay. I can again share it with you. Is it visible?
Yes, sir. Now it is visible.
All right. So therefore, I have the pre-weight and I have the post-weight, because according to the objective, I have the weight of one particular group before the exercise and the weight of the same group after the exercise. So I should define my variable. Then I go to my data view. I go to my data view. Now you can see pre-weight and post-weight. So now I have to enter the weight. I should enter the weight of only those people for whom I have their pre-weight as well as post-weight. If there were some people, they were present at the pre-weight, but not present at the post-weight, then I cannot have their post-weight. And if there are large number of the people of this type, then we should take out their data from the sheet. So if you start with a large number like 200, some of the cases will be dropped, so your sample size may be reduced. But important is you should enter the data only of those people who were present at the pre as well as the post. Now I am just entering the data and I will tell you it is in the kg. I'm just entering the data randomly. I don't have anything. Suppose I have entered this much data. Now I am entering their post data. And see, post data is suppose I've entered the data. Now this is how you should enter the data. Now I go to my analyze and I go to the compare means. And here you can find out paired samples t-test. This is important. So I should now go to the paired samples t-test. And now here I have the pre-weight. So I can shift the pre-weight and then I have a post-weight. I shift the post-weight. So I can compare the pre-weight with post-weight, or I can compare the post-weight with pre-weight. It does not make a difference, because you can always compare post with the pre or pre with the post. But you have to take decision on the basis of the post. Okay, all right. If you go to the option, you see it is 95% confidence or level of significance is 0.05. It is all right. Now you go to OK, and this is the result. Now you can see the result very carefully. And in this case, your pre-weight is 51.83. This is the mean. And your post-weight mean is 57.17. And you know your number, your SD is, for the pre, it is 4.90. And for post is 4.28, and your N is 23. You cannot write 23 plus 23. The sample size is not 46. It is only 23. This is important. That is why your degree of freedom is 22, because 23 minus 1. Okay, all right. And your t value, this is your t value. Okay, and this t value is significant. It is 5.60, and it is significant at 0.01 level. And this has come negative because it is 51.83 minus 57 point. But if I just do like this, once again, I show you so that you are confident. So I say like post first and pre after that. And if I do the analysis, now you see now this is the same t value. Here the t value is 5.6 minus 5.601. Here it is plus 5.601. So the t value remains same. So whenever you have a t value, whatever is the sign, you don't bother, you always write it as positive. You cannot write it as negative. So let me see, how do I test my hypothesis? I don't have much time at my disposal, so I will just try to do it fast. I'm now going to share my document file. Are you able to see my document, my Word file?
Yes, sir, it is visible.
All right. So therefore, now, as I wrote the caption heading for the first objective, I am writing the caption heading for the second objective. Okay. And here it is testing wise. Why testing wise? Because I have pre-test and post-test. So I said testing wise comparison of mean, scores of weight of subject or students, whatever you like. You have said students, okay. So we can say students. Now this is the caption heading, and this I have taken from the objective. So now I can copy and paste and say the second, if this is my second objective, if I say this objective is 2 and this hypothesis is 2, so the second objective was, it has to be in the past tense, was to compare mean scores of weight of student before and after the exercises. Then you say the data were analyzed with the help of paired samples t-test, and the results are given in table 2. So here I say table 2. Okay, and I can insert the table here. Now here I say testing, then I say mean, then I say SD, then I say N, and then I say correlated t-test. Please do not write t-test, because there is a lot of difference between t-test and the correlated t-test. The assumptions of the t-test and correlated t-test are same. Only the thing is this, that you only have one group. You do not have two groups. Okay. And so this is correlated t-value, which you have to write, and I will have one more insert, which will be for the remark. And now here I say pre-test, and then I say post-test. Your pre-test mean is 51.83. Your post-test mean is 57.17. Your standard deviation is 4.90, and your post is 4.28, and your N is 23, and your, I did not just let me, what was my correlation? My correlation was 0.510. So okay, I have to write one more thing, my dear friend. I should write here correlation R, and then here I should write the correlated t value, and then I will have here insert 1 and write remark. Now here the correlation is 0.51. I saw it, and my value is here. The correlated t value is 5.60, and you know this correlated t value is significant. And it is significant at, so I say 0.01. So the p has to be the small. Now here I have to write the heading, testing wise. Testing wise mean SD, N, R, and correlated T value of weight of students. Okay, now I have to now write. I have very little time. Should I give interpretation tomorrow? Because I have only 2-3 minutes. Yes, I think let me do it. Now from table 2, it can be seen that the correlated T value is 5.60, which is significant at 0.01 level with DF equal to 22. It indicates that the mean score of weight of students before and after the exercise differ significantly. Thus, the null hypothesis that there is no significant, I think I have that there is no significant difference. There is no significant difference in mean scores of weight of subjects or students, whatever you want to write. If you want to write students, you can write students. So there is, thus the knowledge that there is no significant difference in mean scores of weight of student before and after the exercise is rejected. Now, once I write is rejected, it means that I have tested the hypothesis. But interpretation is not over. Then you say further, the mean score of weight before exercise, mean score of weight of students before exercise is 51.83, which is significantly lower than after the exercise, where the mean score of weight, is 57.17. It may therefore be said that exercise were not found effective in decreasing the weight of students. So this becomes from here to here. If you take, then this will become your what is known as the finding. So dear friends, I will take the questions tomorrow as soon as we come. So therefore, thank you very much. And if there is something very important, then of course is all right. Otherwise, we can postpone. So thank you very much.
Thank you, sir.
We can close it.
Thank you, sir, for the brilliant explanation that you have done.
All right.
And Gupta, sir, can we have the question answer session or should we postpone it for tomorrow?
No, it is tomorrow.
Okay, sir. Done.
This particular one will go somewhere else now. Okay.
Okay,
So
sir.
tomorrow we will take, no problem.
Okay,
You
sir.
can note down all the questions and we'll take tomorrow. All right. Bye.
Okay, sir. We'll
Bye.
continue with the question answer session tomorrow.
Yes.
Thank you,
Okay.
sir.
All right.
Good day, sir.